Namaskar. Welcome to Supply Chain India, Episode 8. Happy Deepavali. Do you know India imports 85% of its domestic oil requirement and spends around $100 billion every year? This can be reduced substantially if only our commercial vehicles or trucks can adapt to aerodynamic principles. Unfortunately, both the Indian truck manufacturers and buyers are slow to realize the cost advantage to them and the country. Young Pradeep Pandurangi, with aerodynamic qualification from the Netherlands and work experience in Europe in the same domain, has been canvassing for aerodynamic solutions in the Indian trucking segment through his startup AeroTruck for the past 2 years. He joins Rajesh Joshi, a veteran auto industry expert with 25 years exposure, to debate what is holding back the Indian transport community in embracing this huge cost saver to the nation.
I mean, everybody knows aerodynamics, understands that it works and helps improve fuel efficiency. The big question is, why is nobody out there selling the product, right? First of all, the OEMs, they have already tried it. Like Mr. Rajesh already mentioned, Tata has done a lot of work. Ashok Leyland, already maybe 10 years ago, I think they launched a huge aerodynamic kit, which was completely a very good one, but they made it for tractors. But the problem was that it was too expensive, right? As you know, the Indian trucking industry is extremely cost focused, right? So that is one, it was expensive. And the second thing that is there in India is because the bodies are not standardized. There's a huge variety. So the OEMs can only do as much as they can on the cabin. So which is now starting to happen. The completely built cabin are being sold more and more. That's a slow trend that has started. But until now, even the cabin was sold as a cowl and chassis, right? So because the local fabricators are building the body and the cabin on top, until recently, the OEMs did not have much control on the overall shape, right? Only recent last few years, some companies like Bharat Benz, Mahindra, they have made all this only selling fully built cabins, right? Also, Eicher now, Tata and Ashok Leyland are also following the same road. So then, as the OEMs start getting more into fully built cabins and also integrating the body and having more standardized bodies, that is when the OEMs will come into the picture and okay, start offering the kits. So we are still some time away, because from what I see, apart from large fleet owners, the small truck owners, which is the large market in India, still prefer to buy. Not all of them are buying completely built cabins yet, right? So when that happens, along with that aerodynamics, the importance of that and the integration of that will grow automatically. So it's growing, but it will still take some more time, right? So that's on the front of what OEMs have been doing and why it's not a complete product from OEMs is not launched yet. uh, yeah, I mean, the second part is of course the cost, right? The cost structure. And you mentioned about GPS took a long time to become kind of standard. And there I think it's more about, again, the fleet owners and their relationship with their drivers. I think that plays a big part, because with GPS they were monitoring the drivers, and maybe that led to some friction. And also over here, when we talk about aerodynamics, the question comes about fuel, right? That's also again a difficult matter to be discussed between the owner and the driver. So these are, like, let's say, some formal and informal contracts that go on in the industry. Not everything is easily negotiable, right? So when I say that I'm improving your fuel efficiency, the normal fleet owner would say, okay, fine, you're improving the fuel efficiency, but I have a fixed rate of fuel with my driver, Mumbai to Delhi. So he's going to get the benefit, right? I don't get anything out of it. And then you try to tell them, okay, maybe the drivers will be happier driving for you. But that's again an if and but statement. It's not like the owners, apart from large corporate houses who will say, okay, who have the driver on salary, and there are very few of them. The owner doesn't immediately see an advantage unless he's able to renegotiate the fuel with the driver. So that's one thing that's holding back the implementation.
Yeah, Mr. Joshi, like you come from the corporate side, having spent, almost, more, 26 years in Tata Motors as well as Volvo Eicher. Well, Volvo Eicher has been always at the forefront of, doing a lot of, technological, improvements and all those kind of a thing. Like during your tenure in both these companies, what was the level of awareness and implementation of aerodynamic principles while fabricating?
What Mr. Pradeep has told is very correct. Basically, chassis is actually getting sold more and more, and after this truck code will come, mostly this fully built truck will be sold because safety and all these things are becoming more and more important. So this is one point. Then there are other things like awareness is there, absolutely no doubt, because you know that now recently BS6 has come, earlier BS4 was there. So whenever there is a emission change, the fuel efficiency get impacted. And OEMs are always running for improving the fuel efficiency. And if you see that in the marketing pamphlets and all, they write that this is the fuel efficiency with respect to their competitor. And there is always a competition within the OEMs that, fuel efficiency remains a prime focus. I will say it's a number one focus area. So within OEMs, there is a lot of awareness. But yes, initial, if you see in chronological order, as I explained, the tire frictionals were focused, then chassis frictions were focused. Aerodynamics always remains as third because CFD was recently come in India. It is hardly, I think, 10-15 years the software has come, awareness has come, because the advantages of all these things which can impact the fuel efficiency, that was not there earlier days. And nowadays, all these things are very much coming. Like as I explained you in my own projects, actually we were using all these things and we were trying to implement also. But yes, what Mr. Pradeep said, there are other priorities. Like if I give you, like engine cooling is there on the front side. There, if you want to modify any aerodynamic shapes, the styling person will say it is, their styling will get impacted. So styling also is having its own priority. Engine cooling is also having their own priority. So aerodynamics has to actually struggle between other priorities of OEMs and has to get its place. But whatever, there are simple things as I mentioned earlier, like there is a hood which can be placed above the cabin, the gaps which can be filled, the flaring of all the sharp edges across the load bodies. All these things actually, if it can be done without impacting the styling, without impacting the cost that much, and this actually the awareness is there. Only slowly we are picking up. But I will still say that awareness not to the extent of Europe and US. It is because of the simple reason, because adding all these things actually is a cost, and justifying the cost to the customer always remains a challenge. Only if there is a reasonable fuel efficiency gain, then actually it gets justified. And because of CFD and all, now I think cost also can be reduced and aerodynamics also can be improved. And now actually it is getting slowly the acceptance. So now I can imagine that after some times the trucks also will be very much aerodynamic. And the engine hood, the hood above the cabin, that is actually becoming very popular. I have seen almost in all the models. It is not a something which is not talked about. Earlier trucks, if you see, it was not there.
If I could just add on that, because you mentioned a very important point, which is the hood on top of the cabin, which we call the roof fairing. In local parlance, the fleet owners also call it an air cutter, right?
Yeah.
So that's one of the products that we have, which is the best selling product that we have. Now, as you correctly mentioned, everybody is aware that that part needs to be covered. There's a flat portion on top of the cabin that needs to be covered. And almost all trucks that you see today will have something there. The problem is they put a flat sheet of metal, all right, or a straight piece of metal. Now, as you mentioned, we have done CFD to see what is the effect of that. And actually that makes the aerodynamics worse of the truck. So fleet owners know that they have to put something there which will improve the fuel efficiency, but they put a flat sheet of metal or a kind of a boxy metallic thing. So that is number one, actually makes the fuel efficiency worse. Number one. And the second thing is that it is heavy and causes vibration and often damages the OEM cabin. So these are the two things that we have seen with locally built roof fairings or air cutters. So for OEMs also, it's important to have something that is standard, right? Because otherwise, your warranty can get void, and customers will complain that the cabin is getting damaged because of these parts.
Does it fall within the ambit of CMVR regulations? But still, there is no lot of gray areas. People say that, look, there is no clarity. That's one thing. And now, the second question which I want to ask you, Pradeep, is about the cost factor.
First, on the CMVR front, If you've seen the parts that we have made, the roof fairing, which it goes on top of the truck cabin, the side wings, which goes between the axles, and the boat tail, which is at the rear of the truck. So from the roof fairing and the side wings have no impact on CMVR because they fall within the dimensions that I mentioned, right? The boat tail is the one that actually increases the length of the truck, and for that we have made a application with the Ministry of Transport, and there is a discussion going on how to implement that. Uh, there has been a similar waiver given in Europe for boat tails to it's in the basically favor of the government to reduce fuel consumption. So in Europe they have made a new rule that has allowed extension of the body uh, if you are adding a aerodynamic aid, and some years down the line we might have something similar. So apart from the boat tail, everything else is quite legal and within the scope of CMVR. Then coming to the cost. So like I was saying, we have done extensive pilots, right? I will just talk about the roof fairing because again, that's the one that is selling more now, and there is more awareness with regards to the customer. We did almost a 9-month trial with delivery on their trucks that was going between Delhi to Bangalore, and we found that we saved, compared to their old roof fairing, almost 4% to 6%, right? And we did extensive trials with them on this route because it's very difficult to measure fuel efficiency uh, operationally, right? So we have done the CFD studies and computer simulations as Mr. Rajesh mentioned, but then correlating that with real life testing on the road, it's quite difficult because there are so many variables. The driver can, the traffic is different, the driver is different, the route might be different. That's why we tested with delivery because they have a fixed turnaround time between Delhi and Bangalore, about 48 to 50 hours. They have more or less, they had the same drivers. So we had 2 trucks, right? So, and we did that over a long period of time. So you need many data points, right? Along with that, you have to also account for the load variation so that every toll booth, you're looking at the weight, right? You get a slip at the toll booth, there was also a load cell and we got the weight. So we were able to minimize the number of unknown variables, take all of this into consideration, and we did our test, right? So when you put the roof fairing into context and you get about 4% fuel saving, you get a payback in almost 4 months for the number of kilometers that delivery is running. If you say, okay, I'm a fleet owner, I don't run as much as delivery. The delivery is running 15,000 kilometers a month on each truck. I run, maybe half of that. So that will become 4 months, 6 to 8 months. Then you will get your payback, which I think is very good. So I think that's a starting point for us for benchmark. We have put all of these results on our website. All the trials that we have done, 7 extensive trials with DHL, with VECV, also our internal trials. All the information, we have been very transparent. We have put it on our website, AeroTruck, www.aerotruck.in. So that explains all the trials we have done for anybody who might have questions about, how we did our trials, what kind of fuel sensors we used, what kind of GPS we used, which routes we used. So we're being transparent on that front, trying to show that it brings real value and not just some computer simulations.
Well, from a OEM perspective, since you spend time, very huge amount of time in a OEM inside, from research, design, all those kind of a thing. I mean, what is your, what is your take on that? Like aerodynamic things really affecting the look and feel of the truck or whatever it is. Yeah.
See, I just want to clarify the earlier, whatever Mr. Pradeep was explaining. So obviously, this is a good starting point. What actually he's explaining that testing was done and there is a good results coming. But OEM doesn't work like that. OEMs have a very detailed process. And detailed process, the focus is not only on the fuel efficiency, but on durability, reliability, maintainability, and there are many other targets, including cost. So what happened whenever a OEM is testing? He is not only focusing on one particular target of fuel efficiency, but he has to actually maintain the cost target. He has to maintain the durability, maintainability. So one point which actually Mr. Pradeep was explaining that, there is a possibly noise increase or durability problem or reliability problem because of some sheet was put on the top of the cabin, which is difficult because, any OEM, whenever it tests, it is not only focused on the fuel efficiency because they have a very clear target of durability for the cabin, very clear targets of noise and everything. So they have to meet all those things. So they do it in a very holistic way. All the targets actually they keep it in mind before doing or clearing the vehicle for launch. So this is one aspect of it. Second aspect is, Mr. Ramesh, your point that aerodynamics, whether it impacts the styling, yes, it impacts the styling. And that's what there is a culture of cross-functional team in OEMs. What happens is there is a styling expert, there is an aerodynamic expert, or what we call the person who is coming from the fuel efficiency expert. And all these people sit together, and there will be many other experts. Like they actually review, they test it thoroughly. And that testing is also, I want to comment on what Mr. Pradeep was telling on fuel efficiency. Fuel efficiency is a very big topic, and testing of that fuel efficiency is a very big detailed discussion. Probably in this meeting it may not be possible, but I just can explain you that OEMs have actually done a very good work. What they do it is that any running vehicles, not only one vehicle, all across the region, north, south, east, west, wherever it is going, hills it is going, on the plain area it is going, village roads it is going. They measure all the data where all customer can go. And those set of data, they keep it in their bank, and that particular data acts as an input to the testing vehicle. So there is hardly any chance that you may miss out any customer. And they take a very good call that the testing which is done, it is, city condition is also applied, highway conditions is also applied, village roads are also applied. So they have a very good understanding of what type of actually customer usage is there. So there is hardly any chance that they miss out all these things. So that doesn't happen. Only I agree with what Mr. Pradeep is telling that, initially you have to start with something, because you cannot do so much of rigorous testing at the start. You have to start with some idea, take it forward, do the modification. Like OEMs, it happens that a lot of iterations happens. You start with some idea. If styling person is not accepting some point of it, you have to modify the design and, make it suitable with designing also and aerodynamics also. And that is what, it's an optimization of design from both point of view. And that's what is the culture in all the OEMs nowadays. And then, design get finalized for the launch. And that's the process which is followed.
Sorry, we are running out of time. I want Mr. Joshi to give your quick comments.
Yeah, the only thing is the idea is very good, and we should actually keep the test results ready for the OEMs, and we can show it to them that aerodynamics actually how much fuel efficiency improvements are there. And the test process should be very close to the OEMs. Actually, if that can be done, that will help. And if OEMs are accepting, then fleet owners and all other people will actually accept. That's what I can say at the last.
Mr. Joshi, from the OEM side, okay, what they really should focus upon, because at the end of the day, fuel efficiency may not be the prime, criteria. Okay, they may have several other, things. But how to really push aerodynamics with much more aggressiveness from the OEM side?
Yeah, basically OEMs, they start involving the vendors or the people who are supplying all this aerodynamics related kits and all at the start of the program. So at the start of the program, if involvement is more, that will actually, introduce all this aerodynamics, flarings and hoods and everything into the all the models. And that's the only key basically.
Yeah, thank you, Mr. Joshi. Pradeep, your closing comments.
Yeah, closing comments is that aerodynamics of trucks is going to happen. Okay, it's just a question of how fast it is going to happen. I think we have proven now that on-road fuel efficiency can be improved with aerodynamics, even at 50-60 kilometers per hour that we see. And a lot of people are also buying, like Mr. Joshi said, also for styling because it looks better, right? People buy a 20-25 lakh rupee truck. They don't mind spending another 25,000, 30,000 to make it look better, because our roof fairing also makes it look better, right? So styling is also quite an important issue for the customer. So I think along with the improved branding and fuel efficiency, the aerodynamics is only going to improve. And
that was Pradeep Pandurangi and Rajesh Joshi on the slow boat to aerodynamic entry into the Indian trucking segment. Now we take a short break. When we return, we move to Durham University in the United Kingdom. Stay tuned.
Are you part of the new fleet evolution? The transition is already underway. Fleets are using data to manage smarter, keeping drivers safe, streamlining operations, keeping customers satisfied. This requires agility and the right platform. Did you know that 94% of road accidents are caused by human error? What if your drivers had an active coach, keeping them engaged and safe and reducing their stress? And what about your managers? What if you could cut their administrative workload and help them gain visibility and control of the fleet? Green Road supports you with one unified platform. Our advanced active coaching gives drivers clear feedback to help them drive more safely and efficiently, and keeps them motivated via personalized information and friendly competition. In the office, online dashboards keep the right information at your fingertips, freeing you to focus on exceptions and pressing issues. Whether you require an app, an installed solution, or other sensors, all are integrated into a single platform that helps you manage diverse operations proactively across the world. The result? Safe drivers, reduced risk, protection for your brand, and savings for your business. The Green Road platform is quick and easy to deploy at scale, even for fleets with thousands of drivers and vehicles throughout the world. Green Road.
Welcome back. You are watching Supply Chain India, episode 8. First things first. In the previous episode, we committed to GAFEs. Durham University is in Durham, not Manchester. Secondly, Professor Atanu Chaudhri taught in the Indian Institute of Management, Lucknow, not at IIT Lucknow, before moving to overseas. Sorry, viewers. In this concluding part, Associate Professor Atanu Chaudhri turns the spotlight onto India and emphasizes the need to handhold the MSMEs for India to progress on the Industry 4.0 front. Yeah, since you said that you spend a lot of time in the Indian industry also, as well as in academia, tell me what is the level, where does Indian industry stands today in terms of Industry 3.0 or 4.0? Okay, or let me put it this way, what is the maturity level of India Inc. in terms of 3.0 or 4.0? Have they really crossed the bridge when it comes to 3.0?
No, 3.0, most of the manufacturing industry is not just about India. Globally is run by SMEs, right? Small and medium enterprises.
Yeah.
And I will not say just in India, everywhere these initiatives are sort of led by the larger companies. Industry 3.0, and in some industries in Indian context, automotive and their automotive suppliers, Industry 3.0 have been lean manufacturing or using flexible manufacturing systems, or say CAD-CAM. This started in 90s in many industries in India, and many have done reasonably well. So I think Industry 3.0 is quite well entrenched, first of all among the large companies and their immediate suppliers, tier 1. And it is partly industry driven. If the automotive industry was looking for those kind of quality and process, so Industry 3.0, I will not say everybody, but still it has, the adoption level was reasonably high. Many of the Indian companies had got quality awards and so on. But Industry 4.0 is a different ball game. I do see some applications of it, some of the larger Indian companies doing it. But what I doubt is how are the smaller manufacturing companies integrated into this. And this is where some of the Western companies do well. Not necessarily everybody is doing, but a lot of the German smaller medium enterprises have also adopted. Similarly in other parts of Western Europe. In India, I see that is in general there will be a little bit apprehension, because obviously there is a cost and other issues. But there are some companies, even there is a big robotics company out of Denmark, and they have big operations in India now. And I have seen pretty sophisticated robots, universal robots. They have sold even to Indian SMEs even in cities like Jamshedpur and so on. So it's a question of whether the SMEs really see the value of this. And if they think that is going to improve their productivity, that will help them grow their business, maybe even change their business model, enable them to engage with their customers better, I think some of those companies are forward looking and they're adopting. But there is still a lot of effort which is needed, possibly from the different industry associations, to help them train and understand what these technologies can do for them, and so on. So there are certain efforts which are needed.
See, in the matured economies or the developed world, for implementation of this 4.0 or what 3.0 or 4.0, definitely, there must have been some, government effort also in terms of, tax incentives or whatever it is to really push so that, productivity, operational efficiency improves and, the better, like a matrix, economic matrix. That's a scene.
That is not always the case. In some cases, it might be there, but it is not necessarily through tax incentives. But if the industry is very competitive there, even in Germany, some of the machine tool industry or the automotive industry, typically there is a bigger push from the industry rather than the government. Governments create some kind of a conducive environment, not necessarily always through taxes. That is not so much seen in Western Europe. In Denmark, I have seen again, government is not directly involved in this. They have some research projects. They might create a space where companies can come and learn and so on. Finally, it's up to the companies to decide. This is still an individual effort. There has to be, but government can create some kind of a policy guideline. If there are some regulatory hurdles, then government can chip in. For example, for 3D printed parts, what happens if something fails and so on. So there is a lot of, if the part is being used in aerospace or medical devices, then obviously there is a need to develop standards and regulatory processes. So that's where government comes in. But I don't think this should be something which it has to be purely tax incentive driven. There has to be value driven. The company should see the benefits of it and then invest. It helps if some companies work together, some large companies and small companies together, then it helps in the adoption. But I don't think government should get into it. But there is a need of government can help in setting up of training infrastructures. What I see in Indian context is the concept of distributed manufacturing. That manufacturing can happen in even in hinterlands, in smaller towns and villages, and we can produce things which is needed at a localized level, very customized products. And this will also help this government's vision of Atmanirbhar Bharat, right? So this cannot happen unless SMEs are integrated into also these digital supply chains. And I see a lot of opportunity there. India manufacturing prowess is not bad. We have been suppliers to many large companies also. How do we integrate digital manufacturing with existing manufacturing processes like injection molding or casting and so on? And there are some technologies which can help in doing this. And I worked very closely with a Danish SME. They were a large, there was an injection molder. It's a small company, family-owned business, hundreds of years. But they were facing huge competition from China as usual. But using 3D printing, producing the molds using 3D printing, and then finally producing the part using injection molding, they could now produce in smaller volumes, more customized products, and they don't necessarily need to compete with China. So those kind of things are needed in the Indian context of sort of distributed manufacturing.
See, yeah, good that you raised this point. In the current context of globalization, de-globalization, or moving away from, like a China kind, China as a world's manufacturing hub. Okay, we are talking about additive manufacturing or a 3D printing. So, provided you have the right kind of a technological prowess, you can do anything and everything. Within your own country using additive manufacturing or 3D printing, right?
Yes. You can do, but again the question is what is the best technology for your application, right? And I personally believe SMEs have to be involved in this. Whether they finally produce the part using 3D printing or not, that's a choice. That's a technical question. There has to be some evaluation. What is the benefit of producing that part using 3D printing, not just for the sake of it? Similarly, as I have said, there is an increasing opportunity to combine 3D printing with conventional technologies. If you are a foundry or casting, or you are an injection molder, you have maybe 50-60 years of experience. You don't have to throw everything away. If you talk to that SME entrepreneur, you might think that this is something which is going to take my business away. It's not true. You can use 3D printing to produce the molds and then still do casting or injection molding, which will help you being more responsive and producing lower volumes. And you can get much better business results if you follow this. So you have to think of, that's why I think the new generation of entrepreneurs in those businesses, they need to think of how they can adopt latest technologies and combine them with whatever they have already done. We don't need to throw away everything what you are already good at. So there is an increasing need of this synergistic application of both conventional and this, digital manufacturing. Some cases maybe digital is the only solution, but most cases I will believe that they will get better results if they combine digital with their existing conventional manufacturing technologies.
Yeah, one last question, Professor. Sitting, wherever you are, when you look at the entire world, the manufacturing, what do you find? What is a common thread among all the countries? Because manufacturing is, part and parcel. You simply cannot survive without manufacturing. Okay, what is that one common thread which you notice across the country, whether they belong to a developed world or an emerging market or a matured economy? What is that one common thread?
Common thread, as I have said, most of the manufacturing across the world is run by SMEs. It can vary, the percent can vary between say 80 to 90 to even 95%. So manufacturing cannot be learned by just 10 big companies, right? It is a supply chain with many suppliers and tiers of suppliers, and many of them are small. So if your supply chain, if your suppliers are not competitive enough, a single Tata or Mahindra cannot improve India's manufacturing. So that's how this entire supply chain needs to be developed. It has been developed over the years, geared to more Industry 3.0. Now if we have to move that leap, I see India has a huge potential. We have the technical prowess. We also have very good computing prowess in terms of machine learning and big data. But how do we really help these smaller companies to adopt? And that's the biggest challenge. And that's where I think training, doing some feasibility studies, making things work for them and so that they can really see the benefits. It's not some paperwork or somebody coming and giving them some presentation, right? So there has to be some projects, maybe some industry, academia collaboration, partly funded by the government, which is true, which happens very actively in Western Europe. There are many such research projects where SMEs are involved with universities and other bigger companies, and they try out some things to see whether it works in that context. Those kind of things are relatively lacking in Indian context, because the SMEs will not be able to do this on their own. They need help, and that's where the government funding goes on into more research, and then to see whether it can be applied, and if it can't be, then what needs to be done to make it happen. So those kind of studies are needed. I have seen little bit National Productivity Council in India. They have been doing some kind of work on that direction, but I think it's a long way. For an Indian context, for such a large country with so much of variation, we need to focus on again certain industries, certain industrial clusters, do this kind of feasibility studies, see what works, what doesn't work. And many of these things, I say, it has to be also adapted to the Indian condition. You cannot simply copy what is being done elsewhere. So that's why a lot of interesting work, opportunity is there to do such work in India.
This brings us to the end of Supply Chain India episode 8. Hope you liked it. Share it. Subscribe. We are eager to listen to your feedback. Come and please stay safe, stay healthy. Till we meet again, goodbye.